Students, today I am going to discuss Simpson's 1/3 rule and Simpson's 3/8 rule. Now in Simpson's 1/3 rule, we are joining two parts at a time. That means we are joining 3 points at a time. Two parts means 3 points. So 3 points at a time, and when we are joining 3 points at a time, that means we are fitting a polynomial of degree 2. So we are joining this. So for example, here suppose we have this data. This is our data. We have taken this data x0 to x6, x0, x1, x2, x3, x4, x5, x6. We have this data, we have these values. So we are joining these 3 points x0, x1, x2 by a, so this is suppose this is our exact curve. Fine. However, we are joining these points with a approximated curve. So suppose this is the red one. Suppose this is fine. So first we are joining these 2 points, and then we are integrating. So we are finding this area which is this red one, and obviously this will create the error. So we will evaluate the error is due to this area, excess area, and here area is somewhat less than the exact area. Fine. So this will give you the ultimate error. Once we are getting the area in this part, then we will again extend this up to x4 with this help of this. Then again find out the area bounded by this curve, and so on. And finally we will join all these and get the solution. This is the strategy. Fine. So suppose initially we are joining these 3 points x0, x1, x2 by the polynomial of degree 2. Polynomial of degree 2. Fine. So here x0 plus h, x0 plus 2h, f0, f1, f2. If you construct the table, so you will get up to second order difference. The second order difference. So now we are applying Newton's Gregory forward difference formula. So f of x0 plus u of delta f of f0 plus u into u minus 1 by 2 delta 2 f of 0, where u is given by x minus x0 by h. Fine. So now what is our target? Our target is to find out the area. So area from x0 to x0 plus 2h is given by this x0 integral x0 to x0 plus 2h f of x dx. What is f? F is the blue part. This is your f, and red is nothing but the p2x, interpolating polynomial. So here we are finding actually f of x is replaced by this formula, interpolating polynomial. So just when you are replacing this, so what you will get, f of x is exactly this value. So we have replaced this. Now dx, according to this, what is dx? Dx will be dx, this is a constant, so dx will be h du. So this is your h, here is du. Now when x is equal to x0, here u will be 0, so lower limit is 0. When x equal to x0 plus 2h, so u will be 2. Fine. So now here limit is for x, however in the right hand side limit is for u from 0 to 2. Fine. Now integrate with respect to u and substitute the limit 0 to 2. After simplification of this, we get this h by 3 f0 u of f1 plus f2. Fine. So this is the formula. So the area in this part is given by this. Similarly find the area here. So what you will get, area from x2, that means x0 plus 2h to x0 plus 4h f of x will be based on this formula h by 3. Now in place of f0 we are having this point, so f2 plus 4 of f3 plus f4 and so on. This will be going on. So here this procedure is shown here. So first we have evaluated the area. First we have evaluated the area here from 0 x0 to x2, which is given by this or this expression. Then we have evaluated the area from x2 to x0 plus 4h, which is given by this h by 3 f2 plus 4 f3 plus f4 and so on. Finally last part area is x0 plus n minus 2h to x0 plus nh. F of x is equal to given by this. Here the important condition is that n is even. N is even, number of partitions is even. Fine. So when you assemble all these, so you will get h by 3 h by 3 h by 3, so h by 3. Then first and last term, they are single terms. However 4f1 4f3 4f5 and so on, so all the even odd terms will be here, and twice f2 plus f2, two adjacent parts area will having f2. So join to twice of f2, so twice of f2. Similarly f4 twice of f4, and so they will be twice. So this is first and last term plus 4 into all the odd terms plus twice into sum of all the even terms except last and first. Fine. So this is the formula. And the important point is that n should be an even number, multiple of 2. Fine. Now we have to evaluate the error in Simpson's 1/3 rule. Error is due to this excess area or the area less than this, so we are having error. So now study this error, the order of the error. So first f of x, add and subtract x0, so we are having this. Now expand this about x0 with the help of Taylor series, so we get this. Use Taylor series. So Taylor series we have used this, so this is the Taylor series expansion. Taylor's series expansion. Fine. So this is equation number 1. Now first we are taking this part only. So x0 to x2 f of x dx is equal to x0 to x0 plus 2h. F of x, replace f of x from equation number 1, so this is substituted. So from 1 we have this dx. Now integrate with respect to x, so we have this expression x f of x0 plus x minus x0 whole square by factorial 2 first derivative plus x minus x cube by factorial 3 and so on. And limit is from x0 to x0 plus 2h. This is the limit. Now substitute the limit. Final we are getting this integral x0 to x2 f of x dx is nothing but 2h f of x0 plus 2h square first derivative of x0 plus 4 by 3 h cube second derivative of f at x0 and so on. Fine. This is equation number 2. Now from the Simpson's 1/3 formula. Simpson's 1/3 formula is from x0 to x2 f of x dx is given by h by 3 f0 plus 4 f1 plus f2. Now find out these values with the help of equation number 1. Fine. So here put x equal to x1. So put x equal to x1, so we get f1 is f of x0 plus x1 minus x0. x1 minus x0 is nothing but h of f dash x0 plus h square by factorial 2 second derivative of x0 plus h cube by factorial 3 third derivative x0 plus and so on. Fine. Now put x equal to x2 here. Put x equal to x2, so we get f of x2 which is nothing but f2 plus f of x0 plus x2 minus x0 is 2h first derivative of f at x0 plus here we are having 2h, that means 4h square divided by factorial 2 second derivative at x0 plus similarly here this will be 8h cube by factorial 3 third derivative at x0 plus next term will be 16h 4 by factorial 4 fourth derivative at x0 and so on. So this is from the formula. So substitute f1 f2 in equation number 3. So what you will get, this is equal to h by 3 f naught plus f naught 4 times f naught 4 plus 1 5 f naught plus f2 is again having f naught, so 6 f naught. So we are substituting f1 and f2 in equation number 3. So what you will get, you are getting this term. So simplify this. So ultimately we are getting this equation. This is suppose a1, let us say a1. So now we see this is from the Taylor series, equation number 2. This is from the formula. Now take the difference of these two. So just see, here is 2h f naught, here is also 2h f naught, so cancel out. Here is 2h square f first derivative, 2h square first derivative, so they will be cancel out. Next term is 4 by 3h cube, they will be same, so again cancel out. Next term is again same, so they will be cancel out. Only first term which is not same is the fifth order term. So here is fifth order 32 by factorial 5 h5 fourth derivative of f at x naught. Here is 5 by 18 h5 by fourth derivative of f at x naught. So they are the unequal terms. So this will be the first error term. So what will be the error? Error will be this minus this. So here is this error 32 by factorial 5. So here integral minus a1. So this will be 32 by factorial 5 minus 5 by 18 h5 by factorial 4. Simplify this, we get this. Similarly, you can find the error into x2 x4. So this is the error in this part. The error in this part is given by this. Here is f of x naught. If x naught is here, so x naught is here. Now the error in x2 x4 will be same word except this point. Here is x2, here is x2. Similarly, last part will be x at 2n minus 2, 2n. Here I am taking 2n because even number of partitions are requirement. Even number of parts are required to apply Simpson's one third. That's why 2n. So 2n minus 2. So this will be 2n minus. Take their sum. Take their sum, or first we take the magnitude. So magnitude is suppose magnitude of this quantity, magnitude of this quantity, magnitude of this quantity. So here is suppose this is m. So the total error is this part plus this part plus this part plus this part. This is the error. So total error is magnitude of this will be magnitude of this quantity, which is again applied triangle inequality. So less than equal to h5 by this magnitude of this part plus magnitude of the fourth derivative of f at x naught plus magnitude of this. But this is, we have assumed that maximum of m. So m, how many times? M times, n times. So m into n times. So mn h raised to the power 5 by 90. So we are simplifying this. What is n? N is h. H is b minus a by 2n. Even number of parts. 2n. So from here b minus a is 2n minus h this. So you can replace this quantity by b minus a. Fine. So b minus a is this nh. Nh is b minus a by 2. So that's why m h raised to the power 4. Now here is 5, here is 4 because nh is b minus a by 2. So that's why 180 this. So we can say that the error is of order 4 because h raised to the power 4. So this is of order 4. Fine. So this is the Simpson's 1/3 rule. Similarly, in Simpson's 3 by 8 rule, here we are joining 4 parts at a time. 3 parts at a time. 1, 2 and 3. That means 4 points. x0, x1, x2, x3. And that's why the degree of the polynomial will be 3. Cubic polynomial. Fine. So procedure is shown here. Here just first integrating x0 to x3 f of x. x0 to x0 plus 3h f of x. And f of x is nothing but from the just like this, just add one more term here plus u into u minus 1 into u minus 2 divided by factorial 3 third derivative f, substitute it here. After simplification we get this. Fine. Now integrating and after substituting the limit, because here we have assumed that x is equal to u is equals to x minus x naught by h. So limit will be, this is nothing but u from 0 to 3 f of x naught plus uh and du and h. This will be the value, and this is replaced by the formula, this formula. Just replace this value here and then integrate. After this we get this value. Fine, we get this value. Similarly, we can find out the area in the next part from x3 to x6, which is given by this. So that means here it starts from f3, just like here 0 1 2 3. So now 3 4 5 and 6 and so on. After adding all these, we are getting the total area. This is the total area from x0 to x0 plus nh. Here n is should be a multiple of 3. Here n is multiple of 3. This is the main item. This. Fine. And then error. Find out the error. This is the error. So first Taylor expansion. Then put this value in this Taylor. This f of x is replaced by this equation number 1. And then substitute the limit from x0 to x0 plus 3h. After simplification, we get this value. Now find from the formula Simpson 3 by 8. Here is this factor. This is the value. So now find out f1, f2, f3 with the help of equation number 1. So put x equal to x1 here. So we get this value. Put x equal to x2 here. So we get the f2. Put x equal to x3 here. Then we get f3. And then finally substitute all these values in equation number 3. So we get this value, which is denoted by a2. Now you can see we have equation number 2, equation number 4. Fine. So 3h f0, 3h f0, n by factorial 2h square f0 first derivative, n by factorial 2h square first derivative. Similarly, they will be same, third order term. Fourth order term, they are also same. However, the difference is this. This is this. However, h33 by 16, h5 by factorial f0 derivative, fourth order derivative of f0. So difference comes from the fifth order से difference आएगा. So the यहाँ से आपकी error term आएगी. Fine. So error is the difference of these two, which is evaluated here. So the error in the interval x0 to x3 is this minus a2. So we have 81 by 40 minus 33 by 16 h5, fourth derivative of f at x0. Fine. After simplification we get this error. Similarly, find out the error in the next part x3 to x6. Again using this, in place of f0 now we have f3. So here is this. Similarly and so on. And finally after take the sum. So this is the total error. So maximum error is magnitude of E, which is less than equal to 3 by 80 h5 magnitude of this quantity f0, magnitude of f3, magnitude of x6. Suppose this is a maximum m. M is the maximum one. So this, and finally replace nh by b minus a by 3, because here we are taking 3n parts. Fine. So this is by 3. So just replace by 3. So we will get the required formula, and error will be of order h raised to the power 4. H raised to the power 4. So Simpson's 1/3 as well as Simpson's 3 by 8 both are of order h raised to the power 4. Fine. So this is the formula. Simpson's 3 by 8 and Simpson's 1/3 rule. Fine. Thank you.